I've got a lot of work to do this weekend. I have to machine a bar shaft. I have to machine sleeves to match. I have to heat treat and blacken the bar. I have to calibrate it, assemble it, package it, all ready for shipping on Monday. So it's going to be a very busy weekend. So without further ado, let's go ahead and get the shaft in here, ready to machine. It's going to be a Pinnacle Series deadlift bar. So let's go ahead. Okay, you guys can probably see that the ends of the bar are already machined. Quite some time ago, I machined a whole bunch of bars to this point, deadlift bars. So that'll save me a nice little bit of time. But before we continue, I need to put the tailstock back in the lathe because obviously I need that for turning down the diameter of the bar. So I'll go ahead and clean up the ways now and then get the tailstock on. Okay, now you guys probably can't see what I'm doing here, but I'm making sure the underneath of the tailstock is clean and free of any metal dust and swarf as well, because both of those surfaces need to be absolutely pristine or it's not going to be aligned. Oh boy, that did not feel good. Okay, very nice. Then we'll just tighten up this nut underneath. Okay, that's good. Slide this all the way through. Okay, very nice. Now we can put the follow steady on. Now we are ready, almost ready to do some turning. I need to change a couple of tools first. Okay, so this parting tool needs to be swapped for an S-shaped tool. There's that tool. And then we need our knurling tool right here. Okay, now we are ready to machine the bar. Starting with a few little marks to show where we are going to be cutting and machining. 356.5. I think now is probably the time to address, even though I've said it before, you can probably see right now that the bar is got a little bit of a wobble in it. That's because from the supplier, no bar ever comes perfectly straight. And the reason I'm not straightening it before I machine it is because once I heat treat it, the heat treating can warp the bar again. So if I straighten it now, then machine it, then heat treat it, it's just going to be bent again anyway. So I machine it like it is using the steady rest, then I heat treat it, then I straighten it so that I don't have to straighten it twice. Zero that, measure twice, cut once. Set this to 0. Okay. Get another 0 just here. 0 that. 0.09, which leaves us enough to hit with the belt sander to get it precision after we've done the final cut. Alright, so we can slow that down now. Go to RY1. Get a 0 on here. I will now measure that to see where we're at. Aiming for 27.5 right there, which will be a nice diameter to then finish off with the belt sander. 27.53. Very good. Okay, now we can swap tools and then we can absolutely send it. Okay, we are swapping from a 0.8 corner radius to a 0.4 corner radius. And we're swapping from a PS to a PSS chip breaker. The grade, we're swapping from an AH 8015 to an AH 725. So this is going to make sure that we get a cleaner cut. There's never going to be any chips that can get under the under the bearings of the steady rest. And it's going to ensure we can just do one clean cut without, it's also going to reduce chatter. The bigger corner radius you use, the more chatter you're going to get. Okay, so we just swapped from a 0.8 to a 0.4 corner radius with a more aggressive chip breaker and a similar but slightly different grade. And this is probably a good time to give you guys a tip on how you can reduce chatter as a machinist if you're working on long, slender parts or with poor work holding. So if you look at this turning tool here, I'll try to keep it in focus. You can see how the cutting tip is angled downwards a bit. That's called a negative rake. Now, if you compare it to this tool, you can see how this is just straight. That's called a neutral rake. If I put them side by side, you can see how this insert points down slightly, whereas this one is just flat. So you can reduce chatter by swapping from a negative rake tool holder to a neutral or a positive rake tool holder. That's going to reduce the cutting force and it's going to allow you to get a better surface finish. It might have worse chip breaking, so your chip breaker on your tool becomes more important. The other thing you can do is swap from a big corner radius to a small corner radius. I can give you another example of that too. Take a look at these two inserts right here, that one and that one. You see how the tip on this one on the right is bigger and softer than this one on the left. So this one on the left has a smaller corner radius, which is going to, again, it's going to reduce the cutting force and reduce the chatter, allowing you to get a better surface finish. Now, this does come with potential downsides. By reducing the corner radius, you are reducing the strength or the, you are reducing the toughness of that insert at the corner. So you're more likely to get chips if your speed and feeds aren't set up correctly. But if you've got your speeds, feeds, and insert grade selected correctly, swapping from a negative to a neutral or positive rake, and also from a large to a small corner radius, that can help you get less chatter, better surface finishes, better tolerances, and a bunch of goodness. And that's what I use when I'm machining these long, slender barbell shafts here. So hopefully that's helpful. Okay, so there's a little tip for you guys. Now, let's get on to the actual machining. 28 LARY 6. We'll go 800. Okay, we are on 800 RPM, 0.3 millimeters per revolution feed rate, and the depth of cut is 1.3 millimeters. Now I'll just measure what that is before we continue with the pass. It'll probably measure much above 27.5, which will be okay. So it's 27.7. So what I'm going to do is start again. Sometimes stopping the pass and then starting again can get rid of that chatter. So I'm going to just touch the outside of all this sort of wobbly bit of the surface. Then I'll know I need to come in 0.2. Then I'll finish off coming to about here. And then I can hit it with the belt sander knowing that this little point here is good. I just realized that this is super ironic, me giving you tips on how to avoid chatter, and then I've got some chatter on the shaft here. I wish I had footage of what it used to be like before I had the small corner radius and the neutral rake insert with the good chip braking. I would have to machine on like 200 RPM instead of 800, and I would have to stop the cut every like 100 mil to clear chips and to reset it because it was such a bad setup. With this setup, I can usually go all the way along in one pass, or as you see now, 2 passes. The important thing for me is that there is little enough chatter so that I can get the entire pass done. Because remember, I'm going to be cleaning this up with the belt sander because it's such a long, slender part. There's no way I'm going to get anything precise or a good surface finish no matter what I try and do. It's just too long, too skinny, too bad of work holding. So I get it close and finish it with the belt sander. And that's the same as I do for all 3 of the bars. So even though it looks shit right now, you wait till I finish with a belt sander, it'll be beautiful, and most importantly, it will be precise. Now we can hit it with the belt sander to get it to the final dimension. Okay, now before I do any belt sanding, I do just want to measure that part. Good. 27.54 right there, 0.63. So we got a taper there and then a large taper here. Now before I do any belt sanding, I need to put an apron over the ways to protect them from any metal dust getting on there and wearing it out. Just got to put some oil in the belt sander, just a little bit. All right, so I'm just going to stop there and measure it. You can already see that's already looking way better. Wow, that's incredible. So just from that small little bit I've done, this entire shaft now, from the highest high to the lowest low, is only the width of a human hair difference in the terms of diameter. So we're just going to go ahead and do a little more now to get rid of any remaining little bits of chatter that might be in there. Then we'll give it a nice polishing pass. Okay, before I finish it off, I'm going to measure where the knurling is going to be, because these little parts right here, you can see there's a tiny bit of chatter left right there and a tiny little bit left right here and here. If they're going to get replaced by knurling, it's not necessary to keep turning the bar down in order to get that looking pristine. So I got 183.5, 2, 5 and 200. Okay, so the only bits that need to be shiny is all of this, and then also all of this. So, tiny little bit here, and that is literally it. So we're going to go straight to the fine grit belt now, because the fine grit belt is going to take off about another 50 microns just by shining it up and taking off the the high spots. And there you have it. There's a Pinnacle Series deadlift bar shaft machined down to diameter, ready to knurl. Couple little minor bits here, but they're going to be completely erased when we thread and knurl the bar here anyway, so it absolutely doesn't matter. Beautiful. Okay, all of the dimensions here are now in spec. The bar is 27 mil, ready to knurl. Let's go. All right, let's go ahead and do some marking now where the knurling needs to go. precision this time, not with a texter. 0 right there. And we can make a little... I want to move the cutting tip closer to the steady rest. So let's get my 0 point. So 0 that. Okay. We go in 0.6 for the first pass, and this will be 142.5. So 138. Chip there. All right, now we'll run it back for the second pass. Now we are ready to knurl with the knurling tool. Okay, swapping now to the knurling tool. Just a little touch here to find that 0 point. 0 there. Tracking nicely. So the reason whenever I start knurling, you'll notice I start, stop, start, stop, start, stop, start, stop. And that's to make sure the knurling wheel is tracking correctly in the knurl on the bar. That means the little teeth. So if you can see, that means the little teeth of the knurling wheel are going into the grooves that they're cutting. Because if those teeth don't align perfectly, the knurling will do what's called double tracking. It'll just make the knurling feel like shit. It basically cuts a second knurl in between the existing knurl. So the knurling becomes only half as aggressive, and no one wants that. Okay, so we'll bump it up now to 800 RPM. That's beautiful right there. One more check. Oh, that's good. Cool beans. So you guys probably noticed there that as I approach that competition marking ring, it's covered by the steady rest right now, but as I approach that marking ring, you'll see that I blast it with air as the steady rest is approaching. And that's to make sure that any little tiny bits of metal chips that this knurling wheel is cutting, that's to make sure they don't end up getting under the bearings of the steady rest. Because if you don't clear those, they end up rolling and making little indents in what's supposed to be the shiny part of the bar. And they're pretty deep and you can't really get them out easily. And, you know, it's just a sign of poor craftsmanship. So I make sure that that's, you know, being clean as the steady rest comes along. So that's the first section knurled. I'll go ahead and do the second one. Then I'll show you guys how it's looking. Okay, so there is a tiny little bit of double tracking right now. And I'm sure if you're familiar with knurling at all, that there are two camps of people on this. There's camp one, which says your diameter of the piece must align perfectly with a multiple of the diameter of your knurling wheel, and otherwise you're going to get double track knurling. And then there's camp two that says just push the knurling wheel in further. I'm camp two. So what I do is, usually what will happen is I'll have one side of the bar that's been double tracked and one that hasn't. So as it comes around to the side that hasn't been double tracked, I'll just push it a little bit further to kind of cement it into that groove. So I'll do that now. And then it starts tracking correctly. So, and that's why I'm camp, just wind it in. Apply more pressure, because it works 100% of the time. And that's no exaggeration. I should probably clarify, it works 100% of the time if you have experience. When I was brand new, it did not work 100% of the time, but it now works 100% of the time. Okay, speed it up. 800 RPM. Nice. Oh yeah, you're never going to drop a deadlift with that. All right, now it's time to turn the bar around and do the exact same thing on the other side so we can meet in the middle. Okay, what I was doing just there is just wiping a tiny little bit of light oil into the knurl using my Barbell Rescue brush. And I think I should probably address, it's not broken. I intentionally disassembled it because having half works better for me on the lathe. So if you saw this and thought, wow, it's already broken, it's not broken, I just took it apart. So yeah, just rubbing some oil in here to prevent any like flash rusting as I go and take my 30-minute break, which I'll do now, and then I'll see you guys after the break. When I'm turning the bar around, I always need to be very careful that I don't drag the bar shaft along the jaw of the chuck because it leaves a nice big drag mark in them. Doesn't matter so much on, you know, the part that I haven't machined yet, but the side that I have machined, I don't want to leave any marks on there because then it's going to show up and look like shit. And I also need to be relatively careful not to damage any of the bearing race on the other side or this little thread here. Any part that actually needs to be precise or good surface finish, I just need to be careful not to drag that or bash it too hard against the edge of the chuck. Now just make sure there's no swarf. So the jaws will leave a small mark on the nice polished shaft right here, but that's okay because when we're heat treating it, before I coat it in black oxide, I do need to clean the bar and I do hit it with a fine wire brush, which completely takes those marks away. Head and do some marks now. Zero that. Mark a little mark there. So zero that. Zero. All right, now I can slow down the RPM and then turn that down to 27.5 and we'll machine all this down, then hit it with the belt sander. Move this over. After I finish work tonight, I'm going to buy some more oil for the lathe. The coolant mixture is just too watery now. You can probably see literally just over the last 3 or 4 videos, well, by the time this video gets released, it might be 8 or something, but over the last several videos, you can see the cross slide and stuff just starting to develop a little bit of surface rust. I've just been procrastinating, buying the oil. Pump this up to 800 RPM. I'm going to lower the feed rate slightly from 0.3 to 0.275. And I'm hoping that will alleviate a bit of that chatter we had before. Because even though I can get rid of it with the belt sander, it does take a bit of extra time. So I'd rather get a decent surface finish to start with. That last pass I tried to push a little faster than I normally do to save time, but it ended up costing me once I got to the belt sander. Now I'll measure this, find out exactly what the taper is, hit with the belt sander, and it will come up just as good as the other side. Over here, we should have 27.5. Yep, we got 0.55, 0.6 there. And then over here, we got 0.64, 0.68, 0.7. Okay, so we got heaps to take off over here, which is good because that chatter is, you know, fairly deep. So once we take the chatter away, we should end up with a nice smooth bar underneath. Yeah, we got heaps to take off. Just feeling the gap from the polished part here at 27 versus the rest. So we're good. Okay, I'll just give that a quick measure to see how we're coming up. 0.54, 0.55, 0.58, 0.7, 6, 0.59. Okay, so right there is where it's super thick. Wow, that's incredible. The difference from the highest height to the lowest low is 30 microns. Okay, so we'll finish this off now with the green belt to make it nice and beautiful and shiny and polished and scrumptious and every other adjective you want to throw in there. Woo! Wowee, that's 2 microns off. Let's go. All right, the whole bar is now brilliantly belt sanded down to 29 millimeters. The bearing rate is 30.003 or whatever it was. Absolutely marvelous. So we'll go ahead and mark this and get to knurling. Very nice. There we go. We're going to 1/6. I obviously just forgot to zero after I moved it across 5 mil, so wish me luck. Hope it doesn't chip. Woohoo! No chips. Yeah, boy. Oh, I lied to you. It actually did chip. Okay, so we got a new insert now. That does mean I need to re-find exactly where 0 is, however. Okay, it's exactly in the same spot. We got lucky. Very nice. 300 and... There we go. Now we are ready to put the knurling tool on that. Okay, we'll drop it to 30 RPM to get started. Change the gear. Now let's clean this up and get that coolant out of there. Replace it with oil very quick. All right, this bar is now machined, precise, it's knurled, ready to heat treat and blacken. So I'll show you guys the knurling now using my fancy new gimbal. Woohoo!